welcome to this event organized by GoLab and RustLab. It's a two-part event dedicated to both Go and Rust programming languages. We're very happy you could join us here today virtually for this discussion. So GoLab and RustLab, these are organized by Develer, an Italian company that develops hardware and software with industrial applications with a great focus on emerging and open source technologies. So at Develer, we strongly believe in supporting training and collaboration. And because of this, we regularly organize technology events like conferences and workshops and courses dedicated to state-of-the-art technologies such as Go and Rust. So before the beginning of the talk today, I just have a few announcements to make for you all. At the end of the talk, we're going to have our Q&A session. So if you can, please kindly refrain from asking those questions until we announce the Q&A, just to keep things nice and organized. And you can definitely also join our Discord channel to network and share ideas. You know, the party doesn't stop here. So the link is going to be in the chat in just a moment. And today we will go ahead and discuss some questions about Rust and Go in a very free-form discussion on similarities and differences with our speakers. First, we have Steve Francia, and Steve has the unique distinction of leading two of the most successful open source companies in history. First as the chief developer of advocate of MongoDB, and most recently as the chief operator of Docker. Steve is a very active member of the Go community and has served as an organizer of GopherCon and Gotham Go. Next, we have Miriah Peterson, currently a data engineer at Wave in Lehigh, Utah. Miriah focuses on scaling data infrastructure platforms and pipelines. She is a board member for the Forge Foundation, Inc. and organizer of Go West Conference, Women Who Go Utah Meetup, and Machine Learning Utah Meetup. We also have here Michael Snoyman, and Michael is an author and regular speaker around topics including functional programming, static code analysis, DevOps practices, and the boundary between engineering and business management. Michael is the Vice President of Engineering at FP Complete. We also have here Jonathan Turner. Jonathan has worked in open source for more than 20 years, from small projects to large ones, including helping Microsoft transition to open source. He was part of the team that created TypeScript. He also worked on Rust both as a Rust community member and as part of the Mozilla Rust team. Joining us also, we have two people from Develer. We have Naufragi Matteo Bertini, who is a software engineer at Develer. He moved from various languages to Python, and now he works in R&D and looks for solutions to computationally complex problems. For him, finding patterns and beautiful architectures in software remains his passion, and also experimenting with new languages, currently Rust and Elm. And last but not least, we have also Fabio Falzoi from Develer, who is a software engineer. And in the last 3 years, he used the Go language in various fields, ranging from embedded to cloud. And in his spare time, he loves to hack with low-level software and try to get the most out of the Go runtime. So with all of that, I have all of our speakers here with us today. We're going to start with an icebreaker question for you all. You can take turns answering as soon as the idea comes to you. So why don't we start out with this question here? How did you get in touch with Go and Rust? And then what are you doing in Go Rust now? So it's a two-parter. So who would like to start? I'll also put it in the chat for you all if you forget.
Mine would be the most unimpressive. So if I go first, then everybody else can be better after. So I actually started using Go at my first job in software. I had dropped out of a graduate program in physics and got a job as a software engineer, and it was doing Go. So I learned Go as my first non-mathematical programming language, and like I've been doing it, ever since. I still program in it professionally, And I also am one of like 4 people that do Go-based streams on Twitch. So that's like my claim to fame right now is like, you can find me on Twitch. I tried doing Rust on Twitch last week, which I don't know, Rust is hard. So Rust is way harder than I have time for, but yeah. And I like to be involved in the Go community just because, I don't know, the community is the fun part of the language, I think, you know.
So actually, if I could follow up on that, on the note of Rust is a hard language, that's probably how I got into Rust in the first place. I come from the Haskell background about the past 12, 13 years. And Haskell and Rust share a lot of similarities at the type level. And as a result of that, there is a large group within the Haskell community that's been paying attention to Rust, looking at it, trying to glean some ideas. And a lot of people have been moving over to it in some ways. And I decided, you know what, I've been doing Haskell for a while, time to learn something new. And I did pick up Rust a few years ago. Found it difficult to learn at first, I agree. I think that's improved. A lot of the ergonomics have improved over the past few years to make that a little bit easier. And at this point, I spend my time using Rust in a combination with other languages. We find Rust to be really great for creating command line tools, for example. And in addition to that, spend a lot of time on the teaching side of Rust.
I can go next. We'll give Jonathan a little more time to wake up as he's joining us from New Zealand. So I'm Steve. I first got involved with Go when I was at MongoDB. I was running our client libraries team, writing drivers in every language, or lots of languages, and we decided to add a couple more. So we added Scala, and I spent a few months learning Scala first, and then we added Go, and I spent a few months learning Go, and I really loved it. I just was really taken by it. This is like 8, 9 years ago. I can't believe it's been that long. And then I started with it. Before that, I felt like I was a polyglot. I was really excited to learn all these languages. And then once I learned Go, I was like, I'm done. This is my language. And I immersed myself in it. My first project was called Hugo, which turned out to really resonate with a lot of people. And as part of that, I built Cobra, which is another project that resonated with a lot of people. And somehow I tricked the Go team into thinking I could add value, and was able to join Google on the Go team 5 years ago. And now I'm one of the 3 leads of the team. And I'm doing a lot with it. Personally, I write a lot of little scripts and little apps that I use and nobody else does. I don't publish them. Professionally, we're working on generics. We're pretty much finishing up modules, which has been a 3-4 year undertaking. It feels like an overtaking. It took over everything, really. And all the Go releases, and then case studies and papers, articles like the one I wrote with Jonathan, and it sounds like a good transition to him.
Thanks, Steve. Yeah, I think so. Early on, I guess 6 years ago. So not quite the 9 years that Steve has on Go, but yeah, for the last 6 years, I've been working in Rust. Part of that was, as was mentioned earlier, working on the Rust team at Mozilla. So I helped with some of the ergonomics. So hopefully it's getting easier, but I think there's always room for improvement. One of the things I'm working on more recently is a programming language / shell called New Shell, which is like a structured shell that has grown to be a significant amount of Rust code in the last couple of years. So that's been kind of my main focus lately.
Excellent. Thank you for that, everyone. All right, so that was just the icebreaker here. We're going to go ahead and open it up for everything else. So for everyone here, go ahead and enjoy the talk and stay tuned for the Q&A session after the end. So please keep your questions until then. All right, I'll leave it to you all. Have a wonderful time.
Thank you, Latara. I am Matteo. Latara already presented me. I'd like to ask you, starting from a very general question, why do you think Rust and Go exist in the first place, and what problem do they solve?
I think maybe kind of speaking from my background, which is more in programming language design, I think whenever you show a new programming language, the first question that people ask is why? Why make a new one? And I think there's kind of a natural inclination to say, well, can it be easier? Can it be better? Can it be more ergonomic? Can I improve the amount of time that I'm spending writing code? And for something like Go, I mean, it's pretty obvious. The first time you pick it up, there was an eye to how fast you can get from 0 to 100, while you're working in this language. Like other languages may not be designed with that in mind. I think with Rust, there was a different mentality. Can I pick up and have full control over my system in an extremely safe way? And so you get a different set of designs.
Yeah, I'll just piggyback on that. I think there was a bunch of factors that were happening. So this is, from my perspective, we had really three camps of languages, of popular languages. We had the dynamic languages like Python and Ruby and PHP and JavaScript, which promised high developer productivity, but they had limitations on performance. And then you had I call them like the enterprise languages, like C# and Java, which have kind of their own thing, but and then the other set is C and C++, which are all about performance, but complex and not safe. And in the middle, I think Java and C# were the enterprise languages. They feel cumbersome and kind of bloated, and there's a bit of a generalization, but no one's really thinking of them as nimble languages. So you kind of have nimble languages and then really fast languages that are unsafe, and then kind of these enterprise, kind of slower to develop but reliable languages. And so like that was the climate. And I think Rust and Go saw that opportunity and took very different approaches, which we love. We love that they took different approaches to solve the same things. As Jonathan said, with Go, it was the idea of, well, can we have something that's high performance, gives you low level access, but actually takes away features and simplifies things and really makes the experience of reading the language a pleasure, and as easy as possible. And with Rust's approach, they really wanted to go after that high performance place, but in a safe way. And it's crazy how many bugs we have because of lack of safety of these dynamic languages and of these high performance languages, of which both Rust and Go no modern language should be unsafe, or shouldn't have safety as a real focus of it. And that's one big similarity to them, that they saw this opportunity and went after it. There's a bunch of other things like that we can look at. Concurrency is a big driver of both languages as well, and the end of Moore's law. But I think reality was there was just a big shift in the industry of an opportunity for safety and higher performance and more efficiency, and more scalability across multiple developers writing on the same code base. That's a huge focus of Go, and I believe it's a big focus of Rust as well.
One thing I'd like to throw in, from looking at Rust from an outsider's perspective initially, Rust definitely came in with this is systems programming. They're solving a specific problem. C++, C, those are your choices right now. You want to do something real time, you want to write something at the OS level, you're stuck with these languages. They don't have safety. And initially, it seems to me, I wasn't in the boardrooms discussing the development of Rust initially, but it seems that was the goal. Let's go ahead and try to fix that. Let's add in the bare minimum we need in order to get a language out there that can solve those specific problems in a safe way. What's amazing to me is that it has evolved from there into a language that people are happy to write anything in. And now we're talking about applications, front-end apps, back-end apps, mobile apps, everything going on there. So I find that very interesting from the why does this language exist? The why of the language existing in this case has really changed into a completely different ecosystem. I would imagine than anyone ever guessed initially.
Okay, I think, do you want to add something, Miriah, or we can go with the next one?
No, they did it all. I have more. I'll chime in later.
Okay, no problem. So we can go to the next question. Now, suppose that you're about to start a new project. In your opinion, which are the most relevant things to evaluate to pick Go or Rust?
I think that's a loaded question. A little bit. To a certain extent, I don't know. When I pick a project, my projects are usually something really small, high level style, not just like easy. Like my last project was building a web scraper because I didn't have access to the API, or like, let's check out Firebase. You know, just like the projects I do are just kind of fun and on the side. And with that, I always want to go to something that I can spin up quickly and then be done with, right? Like, and for that, let's go. But I think when you're looking at something, especially when you start going into like large scale software, or you're looking at systems design, or you're going into things way more complicated, that's when you start having to like weigh the pros and cons and plus and minuses. And it gets a lot harder. We actually had this discussion at work the other day. I gave him a hard time for not using Rust. My job, we're like 100% Go on the back end. I'm like, guys, why aren't you using Rust? And they're like, well, we just haven't needed to do the memory safe, like to have control of our memory yet. So we're not there yet. But when we get there, Rust will be amazing, because then we can use a lot of C libraries that already exist. So like, I don't know. I feel like you guys will have a lot of insight to add, but I think it depends on the type of project and where you want to go.
Yeah, I think so maybe a month or two ago, Jonathan and I co-wrote and published an article on Go and Rust Better Together. And we spent months researching it, talking to a bunch of companies that were using both. And one thing came out of it that I was surprised by, which was it was a pretty straightforward delimiter, actually, is if the requirements are unclear, or if you know you're going to evolve, or if they're, it's doing something for business and the business requirements will change, then the answer is very much Go. And if you're in a situation where performance matters more than anything else, then the answer is very clearly Rust. And there's a gray area in between those two, right? Not everything fits in one of those two things, but it's surprising how many things do fit in one of those two things. And for me, I thought that was like so insightful, because often, like, I just think of my experience, and like Miriah's saying, a lot of times, most of my things fit in that first one, where like it's kind of exploratory. The requirements aren't really all that clear. We're going to do it, launch it, iterate over it. And then I think of other things, which frankly, I don't write many of these things, but there's, if I was writing something like a encoder for video, I know exactly what the output needs to be. I know what the input is, and those are not going to change because it has to encode it in a certain way. Rust is such a clear answer to use there, because it really, can maximize the efficiency of that process. And especially if you're running that at scale, the advantages that Rust gives there's no other language you should choose. But yeah, I was kind of surprised to have that. It's so clear when we were talking to these different users of both. They taught us that. At least they taught me that.
Do you mind if I ask a question on that? What exactly was leading companies towards choosing Go in the case where they wanted to make the rapid iteration? Was it a feature of Go? Was it an advantage of Go, or was it a limitation in Rust?
Actually, I'll let Jonathan answer, because I think he was the one who actually did the interview that led to this insight.
No, I think that's a good question. I'm trying to remember. I feel like one of the things that came up, if you think about Go, there's an easy way of kind of tear down, rewrite. So if something isn't how you want it, you can just kind of pull that out and rewrite that part pretty quickly. So what people were seeing in this one particular case that Steve was referring to, they wanted to deal with the changing like requirements from business. So next week, maybe the business requirements change, maybe the business logic needs to change. And the speed at which you could just knock together some Go that satisfied those business requirements made that team far more agile than they would be otherwise. And they had a lot of confidence because Go is still, checked. It's still a well-performing language. So they didn't really have to worry about, writing it in like a language where performance might suffer, but you still get that flexibility. Go gives you the flexibility and the performance. So I think that there's that. When we're talking about the power of Rust in that context, the ability to encode that logic as like type system, like almost like little proofs in the type system, was an advantage. So if you had something that was really an important piece of the business logic, you could just write that in Rust and then make sure at compile time that business logic was always, like, that requirement was always met every time you deployed. And so that's like high confidence deployment in that style is available to you, but there's a time cost that's associated with encoding your business logic in the type system. So if you wanted agility, or if you wanted a sense of deployment at high assurance, there's kind of a choice that you make in terms of language there.
That makes sense. So thank you. That makes a lot of sense to me. And I'm glad you pointed out the idea of encoding the business logic at the type level, because that's definitely a technique that I really appreciate with Rust. The thing that I would have said slows me down in Rust in those kinds of situations is, as you're making those kinds of rapid changes, the non-business changes that need to get included as well, the ownership being the primary example. Do I need to wrap this in an arc? Do I need to have a reference here? Do I need to have an owned object here? All the different kinds of trade-offs that are accidental complexity being thrown in. I can definitely see that being a stumbling block that Go, for example, wouldn't have.
No, I think that's really true. And in fact, in the interview, you're just kind of reminding me that one of the things they said was actually a detractor for Rust, which is kind of sad to me because I'm a big Rust fan, but I can totally see this in practice, that having so many choices, having such power and expressive capability actually slows you down. So sometimes you don't want all that choice. You have what some people call choice paralysis. You're like, well, should I encode it this way, or should I grab a macro or really a fancy new type thing that came in the new version of language, whatever. You're Michael, specifically from Haskell. I've seen this in like the Haskell side.
I wasn't going to say Haskell there, but you're talking about Haskell.
But it's a similar friction that's like almost an accidental friction. When you have a very expressive language, you actually hinder how fast you can think and solve a problem. And I think the simplicity of Go is a powerful strength in this situation where you don't have to think about it. Like, there's commonly one or two best practice. You just shoot straight forward, just pick the right one and go. No pun intended.
I think there's one more feature of Go in addition to this that really is what it took me a long time to come around to, why this was so brilliant. But the composable nature makes it so modular and so easy to pull one thing apart and plug another thing in. Just one example, the standard library ships with its own web server, the HTTP package. But because it has the way the composable nature of Go's interfaces, it's actually compatible. Any place that's asking for that, every Go web, almost, at least all the ones I can think of, Go framework or third-party server also interacts there too, or interoperates too. So you can, it's crazy. You can start with the standard library, and if you realize, whoa, I need some features that are in a community package, you can just drop it in. It's really nice to be able to compose that without worrying about inheritance or any of the other kind of more rigid structures. So it's simplicity, and I think this is part of that simplicity that Jonathan's referring to, is that composable nature, which again, coming from an object-oriented background, took me a while to wrap my head around, but it's such a wonderful feature that really gives you agility that I'd never actually experienced before.
Okay, so you talked about memory management and memory safety, and both languages aim to guarantee memory safety. But first of all, do you find this to be a fundamental part of a modern language? And when do you think that the approach of Rust or the approach of Go is worth it? I don't know if someone want to say something.
I have a real life example. Actually.
Very well. Very well.
I just couldn't find my unmute button. So I was actually at work this week. We've been trying to deploy this service, and I had implemented a part that had used a lot of pointers. And I had used so many pointers to the point that I'd implemented them as pointers and then removed them and then redone them and all this stuff. And it ended up that every time it would compile, it would work, we would be able to deploy it, and then we'd get a nil pointer, the reference error in our logs, and that like is the worst error in my experience because it's just like super unfortunate. And my coworker's like, this wouldn't happen if we were using Rust, because the Rust compiler checks that for you ahead of time, and the Go compiler does not, like, hasn't done it yet. And I mean, it's not bad. It's like we were able to like fix it in a matter of 5 minutes because we got the stack trace and fixed the pointer and just refactored our code. We moved super quickly. I got rid of my nil pointers. But just the fact that I was trying so hard to be smart about how I was using my pointers and how I was using my memory, and I thought way too hard about it. And there was nothing there quite to catch me until we had run it and we're deploying it. Thank goodness it wasn't live anywhere. We were like still just iterating on it. But it was just funny though, the fact that I had been doing Rust all last week and had learned about how Rust does references and handles memory, and it just came up naturally. Like, well, if we were doing Rust, it wouldn't have happened. And so, yeah, I think memory safety, memory management is very important. It's something I take for granted now in Go, and I still run into the wall. And I think more and more people are liking that. And that's why we're choosing languages, modern languages that have those safeties for us, so we don't have to always worry about these errors once we've shipped our services or stuff.
I think one of the things I was looking at the other day, and whenever I do this, it sends kind of a cold chill down my spine, is looking at a security review of an application. Like if it's written in C or C++, and this is kind of the lingua franca before Go and Rust came along, the number of exploits that were available to these, like a hacker of these applications, was really scary, just really scary. Even looking at the number of exploits that are available in modern languages can sometimes be like, how did they find that? That sounds pretty scary. For Rust, it's not like you hit 0 in terms of number of security exploits, but all of a sudden you lose all of the exploits that would be, buffer overruns and misuse of pointers and all these kinds of classic C and C++ issues. And I know a lot of these are also taken care of by Go's garbage collection and Go's memory safety as well. So I think as a developer, when you're thinking about, if you're creating web applications, that's one way of thinking. But if you're creating applications that go and live on someone's computer, you really want to button it up, because any little hole that hacker can find can be, quite significant.
Yeah, I'll just chime in. I think the fact that we even tolerated unsafe languages for 40 years is embarrassing for our industry. Like, so many problems result. So many problems have resulted because of that. And I think every modern language should. Rust and Go take different approaches, but they have the same goal of memory safety and type safety throughout them. And the fact that they take different approaches, it makes sense because they take different approaches for almost everything. They really do, but with similar goals, often overlapping goals. I think it's amazing the cost that comes from lack of safety. And it's like these hidden, taxes. Like when you go, well, actually, I was going to use an analogy that makes sense in the US, but might not make sense in Italy or other places in Europe. But when you go to like buy a car in the US, they say it's this price. But then when you go check out, it's an entirely different price because there's like 15 hidden taxes and fees all over everything. It's kind of this, it's a bit of a bait and switch. And I feel almost like the unsafe languages are like that, and that they give the sense of high efficiency, high performance, but the reality is you're paying all these taxes on the back end of nasty bugs, security exploits, and hard to debug problems. And it's just this extra cost that you don't realize you're paying up front as a result of lack of safety. I think it should be fundamental for any modern language. And I hope we never have an unsafe language again. I think between Rust and Go, they've proven that either approach is successful in safety, and really you should be using, one of these existing approaches.
And now perhaps you touch it. I have a question on another big part of the Go language. Go is born with support for concurrency built in from the one. What do you think about the Go approach? And do you think Rust is going to offer a similar developer experience, or perhaps it's beyond scope?
I'll talk for the Go side. Go's support for concurrency is brilliant. Full stop. This idea of lightweight threads is kind of the actor model, like the traditionally you'd call it technically, but that plus channels at high performance, and all of a sudden that is like your main model that you're building things with. We had some languages prior to Go that were successful in their domains, like Erlang as an example, but Go is the first one that hit the mainstream and hit it hard and fast, like in terms of people understood it. That was one of the first times they really got it and they picked it up, and then that became like an effortless thing. People are then writing concurrent code just like over a weekend of just dabbling, and then they come out on Monday morning and they're ready to start writing some serious code. I feel like that's just like a brilliant piece of design to allow developers to hit that ground running like that.
Jonathan, you're probably the best person to answer the second part too. Of like,
should I go for it?
Yeah, keep going.
Okay, so the Rust, I would say the Rust design is really firming up. So we have async await, which grew out of the C# world, and a lot of languages picked it up, JavaScript being one of them. And this ability to write your code synchronously, and then to go back through and sprinkle in annotations that then lift that code into a more concurrent state. And that's kind of the way that at best it works. I think in some cases it does kind of work like that. And for Rust, I see that this concurrency model, this async await, as that continues to mature, is going to feel pretty darn good. I think we're at a growth stage now where we're getting more of the ergonomics in place. We're getting the library support in place. So it's kind of growing towards that. There's also the parallelism side. So we kind of use concurrency and parallelism, and forgive me, my academic background is going to show through in a second, but parallelism meaning being able to run on multiple hardware threads at the same time, and concurrency meaning that you can take tasks and interleave them. That might be on a single hardware thread, or that might be on multiple hardware threads. So being able to then take your workload, break it apart, and run it on multiple hardware threads is easy in Rust. It's so easy it looks fake. So you write your code in a straight line way, and then you put par iter in front of your iter, something like this, right? You download one crate, you put one word change, and now you're running on multiple hardware threads at the same time. So all the safety guarantees that Rust uses for memory safety apply to running in parallel safely. So you get maximum performance without really having to rewrite your code. Yeah, it really feels like a superpower of Rust if you want to go down the parallel path. Again, it doesn't even look real when you first do it.
I'll chime in on the ergonomic side. I wrote a series called the Rust Crash Course on my blog. Course 7 was covering Tokyo 0.1 version of async, well, before async 08. That was one of the hardest blog posts I've ever written in my life. It was difficult. It's hard to understand the ownership. It's hard to see what's going on. You're in closure hell, if we can call it that. Ownership can go in all over the place. I think it was like 6 months after that, maybe a year after that, that async 08 landed. And then I got to completely rewrite the thing. It took me like an afternoon. And it was like, okay, yeah, that's the way it's done these days. So I'm definitely seeing those improvements. I still think that there's a lot to be learned for a newcomer with async 08. And I think the ownership really does interact in a difficult way, which is probably it's a necessary evil, but it's still an evil for the learning curve. In the defense of Rust, or in the benefits of Rust on this, I've seen Rust be able to pick up bugs that no other language can really pick up by the send sync trait system. It's able to prevent you from using the wrong kind of mutable variable when you're trying to do concurrent code. It's able to push you in a direction of writing code that's more efficient in some cases as a result of this, and definitely safer. So I've been very happy with the Rust experience, even if other languages with the green thread kind of approach overall probably are easier to get started with.
I'll just chime in a little. Jonathan, I loved what you said, and Michael as well. Because for those who are new to Go, Go is a concurrent language, and we have these channels and the CSP approach, like Jonathan described. And since Jonathan talked about concurrency and parallelism is separate, in Go you only write concurrent code, and the runtime takes care of seamlessly parallelizing it for you. And so if you write good, safe concurrent code in Go, which is easy to do, it's the straightforward best approach that the language kind of encourages you to use, then the runtime can parallelize that. And it's amazingly efficient, both for the developer and on the system, similar to Rust. So there's a lot of similarities in this. And I'm excited to see Rust progress here, and then push the envelope forward. It's clearly a need for all languages to address. And I think Go kind of saw it early on. Like, this was one of our core features at the very beginning of designing Go. And like the reason we built a garbage collector into Go is because of the need to want to support CSP, this concurrent style of programming. And so a lot of decisions were made as a result of that being a pillar of Go. And it's great to see that Rust is following a similar path.
Okay, I think we can go with the next questions. So talking about expressiveness versus readability, I think that Steve and Miriah talked a little bit about this earlier. It is said that Go prefers simplicity and readability over the number of features, maybe, while Rust is for sure powerful, expressive, but maybe a little bit complex. And in general, I would like to ask if you agree with this statement, even if, well, you already talked a little bit about that, so I think yes. And do you think that the foundational differences in the language design have an impact on real-world applications development?
Well, from my experiences doing Rust from zero, like, I didn't know what I was reading at first. I decided that for me, I can pretty much just look at Go code and figure out what they're doing by experience. I mean, gross code's gross code. So if somebody doesn't write it well, you're not going to know what's written no matter what language it's in. But this past week, I tried to do something that I thought would be trivial. I really thought that I could just pick up Rust and write a little API that queried the Twitch API to tell me who was streaming on what topic. So I could just start to gain statistics on that. And after about 2 hours, I still had no clue what I was doing in Rust. I had no clue what I didn't even know that there were macros. I didn't know what this async business was. I was trying to figure out which of the 5 different HTTP packages I could use were. And I was like, man, if I was doing this in Go, I would have been done an hour ago. And so I thought it was kind of funny. But as I stepped back, I was like, okay, day 2, I'm going to step back. I'm going to pull out the documentation. So I went back to the book, which is what Rust documentation apparently is called, and started going through things and going through it chunk by chunk, understanding how they wrote their functions, more about the syntax. And it's not quite as close to reading English as I feel like Go is, but it's still very programmatic, very organized, and very concise. I don't feel like it's super verbose in writing, at least in what I was able to do. And by the end of last week, I was a lot more comfortable with reading Rust. Do I feel like I could go whip out an API? No, not as quick as I could do it in Go, but I've only been doing it a week. So like, you're saying, does that impact real world applications development? Well, I think, yeah, like we're going to choose the best tool for wherever application we're developing. If it's an API, for me personally, I'm going to do it in Go. If I want to go build something to go communicate with my toaster, I'm probably not doing that in Go. So, you know, it depends on, I think, the use case.
So I'll add a little bit here. I think one of Go's superpowers is its readability. I remember back 9-ish years ago when I started, there were no books yet written. There was the language spec, Rob Pike's Effective Go, and the standard library. And that's how I learned Go. I actually learned it I read the spec, which is really short. I don't remember how long it took, maybe an hour. Mostly grokked it, honestly, which surprised me. I was like, it was very encouraging that I could read the language spec and like come away with it feeling like I understood most of it. And then I just started reading the standard library and looking through it. And I shocked myself that I could read the code. And like I rarely encountered something that wasn't very intuitive to me. Like there was a little bit of channels and how you pull from them that was kind of a new syntax that I hadn't seen before. And but for the most part, it was like really straightforward and readable. And I think that holds well today. Like it's pretty easy to look at any Go code and figure out what's going on. And how that translates to applications, you know, people much smarter than me have said that software engineers spend most of their time reading, not writing. And especially when you're on a team but even if it's just yourself, a lot of the time you're going to spend is reading code you wrote before and trying to put that back in your mental state of what's going on. But if you're on a team, that's times 10 because you're reading code that you didn't write, someone else wrote, maybe with a different style or a different approach. And so the ability to just read it and grok what's happening and carry on, I think is really Go's superpower. And there's an interesting property of Go that comes as a feature of this, which is in you know, we're all developers, so I think we can all relate to this. When you're on a team for a while, you start realizing people's like fingerprints. Like you can look at someone's code, you know, if you're on a Python team or a JavaScript team, and you look, you're like, oh, all right, Susan wrote this because I can tell this is how she does X or Y, and you kind of get these fingerprints on things. And Go doesn't have that. In fact, Go it's a really boring language in that sense, in that it, like, you know, I look over the code our team writes. I have no idea who's writing, even though I've been on this team for years. It's just like good Go code just looks like good Go code, and there's really one way of doing most everything in it, and it's really hard to put fingerprints on it. So I think that's one of Go's superpowers. I don't think it's one of Rust's superpowers. Which is why I think it does kind of speak to the way that one of Go's strengths is really on that developer productivity and scale across teams.
Well, maybe just to kind of counterbalance Steve. I think he's right up to a point. But one of the things that I thought in practice when you're using Rust at scale is that while you can definitely tell who wrote different parts of the code base, so it definitely has that fingerprinting thing that Steve was talking about. One thing that Rust gives you is that if I'm looking at a PR that just came in from someone I've never met, there's so many things I don't have to think about when I'm looking at this PR, because I know that the compiler is checking behind the scenes all kinds of things for me. So I can just look at it and say, are they solving the bug? Is this the correct solution? That's it. So if everything else is building and running, all that type system, the borrow checker, everything is kind of checking a bunch of boxes for me behind the scenes, that for me as a reviewer really expedites the process, that I really appreciate.
I was going to +1 that on the Rust compiler. I think that's my favorite thing about the Rust compiler is by the time you get it to compile, you know it's good working, code. Like there's just a lot of things about that compiler that just saves you headaches, especially in like code review, PRs, or establishing the functionality, like the underlying functionality of, a working program that may not be the problem you're trying to solve, but there's a lot more into your code than just the one problem you're trying to solve.
One thing I'll point out about both languages is I love the fact that they both rely on formatters. So that's at least one set of fights that doesn't happen anymore.
Yeah, +1.
And for those not familiar with what that means, there's GoFumped, we say GoFumped. I don't know. Do you say RustFumped?
I say it because GoFumped is GoFumped.
I have also been saying RustFumped with the caveat that I have no authority to say that.
So it's just a command line tool that's part of both distributions that automatically rewrites all of your code to a standard format in both languages, and it's wonderful. It's one of the best features of, I think, really both languages, because it increases readability and consistency a ton, and avoids all arguments. It's just a wonderful feature, and most editors do it on save in both languages, so you don't have to like call it or think about it. It just, you write your code and then it just looks beautiful. Well, as beautiful as it can look for code.
I can't imagine going back to a language where you don't have that anymore. I truly can't. Like, just turn it on CI, have a little CI check that they've run the formatter, and there's so many arguments that you don't have.
I think it's time for a break. Okay.
Yes. Yeah. Hey, everyone. We're going to go ahead and take a 5-minute break. So go ahead, get some water, whatever you need. We will keep the countdown going for you so you'll know when we start again. So enjoy the break and see you in 5. All right, everyone. Welcome back from the break. Let's see, we have pretty much everyone. Okay, we'll just wait for 2 more. Excellent. Okay, we're all back here. So we're going to start with part 2. And for anyone who has questions, please stay tuned because we will have the Q&A afterwards. So please, please, please be patient with them. All right, I'll leave it to all of you. Enjoy the second part.
Okay, thank you very much. And we left us talking about tooling and GoFumped RustFumped. And again, about tooling. What can you share from your experience in solving complex problems in Go and Rust about the tooling you use and what helped you? And what approaches you can suggest to deal with hard to tackle bugs in both languages? On your choice.
So I'll give my standard answer on that, which is define your types very clearly, leverage the type system, and this is a Rust version of an answer. So use the types as much as possible to encode invariants, make impossible states unrepresentable would be a Haskell way of saying that.
So one of the things that happened in the last couple of years, when we're talking about tooling around modern languages, so there's a system called the Language Server Protocol, which allowed languages to open up their compiler internals to IDEs more directly. So an IDE could interact with the compiler itself or a separate tool, and then get information about the source code. It has a lot more smarts by default. Now, up to this point, IDEs had to write all that themselves. But now with this protocol, you could reach in and get more information very easily. So for Rust, for TypeScript, for I believe Go as well has these language server protocols, modern tooling has grown quite a bit across the board for languages. For Rust, there's a tool called Rust Analyzer. If you want to get into Rust, definitely install this thing. It's really good, and it's getting better by the week, where you can get an array of different, like not just refactors, but ways of looking into your code base, jumping to the implementation type, or jumping to the definition, or looking for all the references for various things in your code base. So I would definitely recommend that. I was just playing with, if you're an Emacs person, and some of us still are, you can just plug in all the same tools and get the same benefit. If you're a VS Code user, of course, you have that available as well.
So I think one of the great strengths of both of these languages is their tooling. They just both have a fantastic set of tools. I'm more familiar with the Go side of things, but Jonathan made a great point last one of how much the Rust compiler really gives you. It is such a powerful tool. And it really is one of the defining features, I think, of that language. The Go compiler is also a really strength, but in a very different way. The Go compiler's big strength is it's in its speed and efficiency. It just compiles, and that iteration time is so fast that you really can, interactively kind of debug your thing, even with like printf statements. But I think like some of the things I'll talk about Go, and I think there's similar equivalents in Rust. We've got profiling built into Go. It ships as part of the standard library. We've got unit testing and function testing built into Go. It's Go test. We're working on fuzzing, which we've started talking about publicly, that we're going to be shipping with Go as part of it. And so there's just all these rich tools, and we've got our own language server. It's called Go Please, which connects to VS Code and Vim and Emacs and a bunch of other things. So it's just, the tooling's really strong, and it's a really strong story, I think, for both languages. I don't think you're making a bad choice with either, and the tools help so much. I mean, it really helps. We've got great debuggers and just a lot of great tools.
So, yeah, maybe to kind of go to the question itself, like how to deal with hard to tackle bugs. Sometimes these are going to pop up, especially as your application gets larger. Maybe there's a performance issue you're trying to track down and whatnot. The Go compiler will output code that has, bog standard debug symbol information. So you can open up Visual Studio, or you can open up your GNU GDB suite of tools if you're on Linux, and all of these just work, right? You get all the demangling of the names. You can step through with the debugger, because people spent time making sure that this felt like all their tools in your various ecosystems. So I think that that kind of work sometimes goes underappreciated, but I think when you're actually tracking down that really difficult bug, not having to come up with some new solution, but being able to just use the tools that you have, really is quite nice.
I think a lot of finding difficult bugs comes to comfort with your ecosystem that you're developing right in. So I have people give me flack about it, but I use Vim, and I have only been developing for like a few years compared to everybody else, and I still use Vim. I've talked to people who come from Java, and they're like, how can you do it without an IDE? And I'm like, well, I have all these Go tools. Why do I need an IDE? And then you have people that come the other way around, and it's like, they do everything with a command line. Like, but it plugs into my Vim. Why do I need to go do the tools in the command line? And I'm all constantly learning about tools built into the Go standard library I didn't know about. There was a talk at Go4Con last year by Jana Dugan, and all it was here's stuff in the standard library that that's tooling that you didn't know was there. And I'm like, I had no clue about any of these. And just, I mean, I have no authority over anything in Rust, but it works with my Vim. It formats on save. That cargo build, cargo is amazing. I don't know what it does, but it as far as like explaining where your errors are, helping you try and fix them, like it's a really great tool. Very similar. It is very similar to how I expect the Go tools to work. So using cargo coming from Go was very comfortable, very nice. And I don't feel like I'm losing anything interacting with those via the command line or with Vim that I would expect from an IDE, where I can have the step-by-step debugger, all that old fancy stuff that I haven't touched since college. You know, I think when you're tackling hard bugs, you want to feel comfortable and you want to be able to not be hindered by your environment. And the tools that are just provided out of the box I have not been hindered at all. And I can just, you know, start following the logic and the process and do the basic things that help identify where the bug is and find the solutions afterward.
I just want to give a quick shout out to Esteban and the error team for the Rust compiler that have been working extremely hard over the last 6 years to make them just quality error messages. I think that's really a really sweet thing for Rust.
I actually wanted to make another error comment, but on the error handling side within an application. One thing I've really liked about Rust is with libraries like Anyhow, it becomes very easy to add contextual information to the errors. So when you're debugging something that crashed in production or on some user's machine and they've just given you whatever was spat out by that, being able to make sure that you have enough contextual information to figure out what was the program trying to do, what URL was it grabbing, what file was it opening, why was it doing those things. That's wonderful. And it's unfortunately, in my opinion, it's unfortunately something that the language can't force you to do. It still requires a lot of discipline to do it correctly, but at least the language is making it easy to do the right thing.
Okay, cool. So let's talk a little bit about libraries and dependencies. We know that both languages offer a modern approach to manage external dependencies. And can you highlight the perceived strengths and weaknesses? I don't know if Steve maybe wants to say something, because I remember that he talked a little bit about the modules in the first part of the talk, but you know, the question is for everyone clearly.
I can start, that's fine. So Go got, every language gets some things right and some things not quite right. And we learn and we iterate and evolve. One thing that Go got really right was our import statements are canonical URLs. So there's no registry that needs to say, I'm the HTTP package or I'm the Cobra package or whatever it is, because everything is a fully qualified thing. And that's amazing. That was a really good decision. However, we underestimated, a big mistake we made was we didn't include versions with that. And a bit of this is historical. Google operates differently in that we have this monorepo and everything is always at head. There are no versions in the monorepo. And so that kind of mentality was baked into it. But the reality is that's not how the rest of the world works. That's not how external dependencies work. And so we realized we needed to evolve and incorporate versions into it. And this was a multi-year project to build modules. And our goal here was to retain the simplicity of the early design, but add versions into it and intelligence around those versions. And you know, one of the great features of Go's early one was we had no diamond dependency problem. And there was no dependency hell. Of course, with everything always being at head, you can't have diamond dependencies because there is no versions to have, you know, any of those things. And so we took a very novel approach in designing Go modules that makes it so we still avoid those two problems. And using Go modules, well, they're not perfect and we're still ironing out a handful of bugs left. For the most part, it just works and it works beautifully. I think it's a really nice system, and one of the nice things about it is it's totally decentralized. And so you can host on GitHub or GitLab or your own private server, or Google Code or any place that you want, and the Go tooling just works with it seamlessly. Of course, Cargo was also one of our inspirations, and I think one of the big strengths of one of the advantages of kind of going last in building a modern system is we got to look at the smart decisions that Cargo made, and Ruby Gems and NPM and all the other ones, and really spent time with their authors and kind of looking into it as we designed the Go one. I think I love where modules ended up. I think it's a great system now, and it's really designed to be as simple as possible while giving you all the flexibility you need. And the community's largely come around to it. It was a big shift that had the whole community had to come to it. And at this point, I feel like we've been largely successful at that. And hence we're kind of returning our attention now to our next big problem, which is to tackle, which is generics. But we could talk about that later if people ask questions about it.
Just kind of following on from what Steve was saying, Cargo, to my mind, was one of those superpowers of Rust early on. So it was part of Rust before Rust was even 1.0. The whole community just immediately kind of latched onto it and then began growing an assortment of different crates on crates.io, which is like the main crate repository, though you can use other repositories, especially if you're a large corporation and you want to have a private repo, you can totally do that. But a lot of crates are shared in one place, so it's easy to go find, where do I do the HTTP crate, where do I get an FTP crate, something like this. The nice thing about starting it so early was that over the years, we've just kind of continued to improve what does it mean to be a published crate. So there's a site called docs.rs, which takes all the automatically generated documentation from each of the crates, puts it up there in a searchable format. So it's all like nicely styled CSS and searchable. And this gives you a sense that it's not just the standard library documentation that is nice and searchable in this way, but that extends to the entire ecosystem of published public crates. So you can kind of just seamlessly use the same muscle memory and really get a lot of benefit from this crate ecosystem. And as a result, I think the crate ecosystem has kind of exploded. Like when I joined the Rust project at Mozilla, it was like 5 to 10 crates a day. I think it's 40 to 50 to 60 crates a day now. In terms of, it's steadily grown to this point where a lot of people are contributing to these kind of common repo.
I have to piggyback on that because that'd be unfair to my team if I didn't. So Jonathan saying this made me think of a big part of our module's effort, which was package.go.dev, and it's pkg.go.dev, which is effectively both of those sites that you mentioned, the crate site as well as the doc site in one. So it gives you documentation as well as discoverability and searchability across this. So we kind of centralized discovery for this decentralized publication of Go, which I think is a super, it really propelled us forward. Decentralization was important to us, but discovery in one place was also important. And we said, how can we accomplish both those things? And this idea of package.go.dev is the answer to that. So, and of course, honestly, again, we looked at crates as inspiration as well as some of the others. So, a lot of times people think that these language teams are competing with each other, and the reality is we're all playing the same game, and we really there's a camaraderie about that, and we really benefit from each other's experiences and learnings, and there's a lot more conversations between teams than probably anyone realizes. But we celebrate when other teams have successes, and we'd like to learn from their successes and failures, and we hope they do from ours.
Changing a bit our target, both languages has promises about stability of the language, and so reach some point of maturity. And so the question from the developer side, is, will my project build again in 10 years? I have LTS release to maintain. And is this on the language side a superpower or a burden?
The Go one's an easy answer here. So far, since Go 1.0, we've had a compatibility promise, and any code written for Go 1.0, with the exception of some obscure security fixes that required some changes, will build today. And we're at, 10 years later, over 10 years later. We debated if we needed to iterate to Go 2.0 when we introduced dependencies and modules and generics. We're happy that we didn't. We found a solution across those that was able to extend the language without breaking backwards compatibility. And so at this, I don't know when Go 2.0 would happen, but I can tell you it's not on our roadmap anytime soon. And our real hope is that in 10 years, your code from today will compile with Go.
Yeah, I think the same thing is true for Rust. So one of the questions when we were before, like we hit 1.0 and then we're starting to look into, will there ever be a 2.0? And around 2018, Rust 2018 being a major version of Rust, like the first major version of Rust to follow 1.0, there was a lot of questions. Should we break back compatibility? How should we break it? How will the tool support it? And the cargo tool that goes with Rust ended up being a very interesting solution into the problem, where in your cargo package, in the configuration file, you can just say what version of Rust you want. And it doesn't matter what version your dependencies want. Like they each can pick their own version of Rust that they want. And all of this compiles down to this intermediate representation that is supported through all versions of Rust. So it really gives you a lot of flexibility in terms of, yeah, we can continue to improve the Rust language. Like if we need to make a breaking change, we can. And we did so in 2018. We're going to do so again in 2021. These little improvements that we need to make in the language to make sure that it continues to grow. But we can still support all the old versions because it really is a kind of the supported intermediate representation that these things compile down to. And we can just switch whichever version of Rust, depending on what you say in your configuration file.
To answer the question of superpower, I say yes for both languages. I have done a lot of machine learning dabbling in my time. And when I started getting into machine learning, it was about the time that they were really pushing to sunset Python 2.7. And so I wasn't involved in it, but I was able to understand, read, and hear the complaints as I was trying to learn Python, and people were pushing me to never touch Python 2.7, only stick with the 3 and up, and do all those things. And it's really nice to not have to worry about that in either of these languages, to not have to worry about a version, to not have to worry about if I'm on Java 7 or Java 8, or if I'm on, I don't know what PHP does, but just PHP 6 or 2 or 5, just to be able to write Rust or just be able to write Go and not have to worry about versionings or weird things like that. Helps with dependencies. It helps with thinking. It clears. I can work on solving problems and less on maintaining, weird things. And it was a really nice. I mean, that's one of the reasons why I ran so fast from Python machine learning to machine learning and Go, is because I didn't have to worry about what version I was using. I could just do the machine learning, and it was just great and easy. And I think that's definitely a superpower. And I think the communities like it so much that it would be really hard to be able to start with not having that kind of compatibility.
So I'll add one extra thing here, which is kind of part of the question. Ryan made me think of this. Is Go has an extra feature here, which is not only will it continue to compile and build, but the language has been so stable for 10 years. in that libraries written 10 years ago still feel like libraries written today. Like it doesn't feel like it's a different flavor. And so like, you know, other languages like Java's had great compatibility, backwards compatibility built into it, but old Java things feel old, and it definitely feels like it's a different language. Now, with all that said, when we introduce generics, there's going to be an element of that that won't be as entirely true, although I really believe that most libraries don't need generics and won't change at all. There's a handful of places that will and take advantage of it, and you know you'll notice that, oh, this could be, if this used generic types, it would probably work a little more efficiently. But even with that, it'll still feel like Go and look like Go, and that's one, you know, awesome thing. Like you look at a tutorial from Go from 10 years ago, and it's modern. It still is the exact same way it would be today. And that's you know, honestly, like you say, well, it feels like you're standing still, and it's a lot of effort to feel like you're standing still and make 10 years of progress. Like it's really, I give our team a lot of credit for, you know, our strong ability to say no to a lot of things and really keep our focus on that consistent experience. Even though we added features here and there, it still feels very, very consistent and stable.
Just to piggyback for Steve and Go. I mean, when you work on programming languages, there's the temptation is so strong to just add something, make it, oh, but if we just added this one thing, this one use case would be so much nicer. And a superpower of being able to do a Google search and then an article pops up that was 5 years old, and I can just copy and paste that code and no one looks at me funny, is a superpower of Go, and really isn't a superpower of Rust. I'll just be honest. Rust's best practices continue to evolve, and year by year, if someone sent me code and I look at it, I can almost tell you what year that was written. It has that fingerprinting that Steve was talking about earlier.
Okay, so we talked a lot about the similarities between the two languages, and we touched the point of documentation, and one single preferred way to write and generate docs seems to be the modern language way. But in your opinion, what's next for the modern language regarding documentation, and not only documentation?
I'll throw one in here, but I'm curious what other folks are thinking too. For Rust, there's like a standard documentation format that you write in, and then it generates your API docs for you. But one of the nice little additional +1 extra things in there is that it will test the tests that you write in your documentation, called your doc tests, as part of your test suite. So you're running your test suite, you accidentally broke one of your examples in your API docs, we'll catch that. And I think that it's a nice little feature, but it really does keep the quality of the output that you're writing in Rust just that much higher.
I'll throw in something in a very different direction. What we're talking about right now seems to be API docs. And API docs are wonderful and they have to exist and you must write them, but they're not nearly sufficient. And there isn't really a lot built into when you're writing code in Rust, Go, or as far as I know, any language really, that encourages writing tutorial style documentation that's really going to be able to onboard users. And I don't have a design for how that should look. That seems like a complicated problem. I'm not sure if it can be solved. But if I had a wish list for how to make documentation writing better, it would be while you're sitting there writing the library, you can very easily go ahead and write a tutorial. The code is going to be, the text is going to be tested against new versions of the library. That same kind of integration that you were just mentioning, Jonathan, would exist at the tutorial level as well.
I love these ideas. Honestly, I hadn't thought of that. And boy, Michael, that would be powerful. Food for thought. I think, you know, so I'll just say what the Go team's working on. First, I love auto-generated docs. I love both Go and Rust's approach to them, which is not as heavy-handed as some other languages are with it. And I think, so we're doing a lot of work on package.go.dev to modernize the experience of those generated docs, to do more, you know, connect symbols across different things. So it's not just the docs of this, but it also can connect to other, related docs. Maybe you've imported something and it can kind of embed things and bring that all the way from not just the documentation website, but also into our Go Please server. And so we're really trying to connect the documentation all the way to the end user in the variety of places where they might find it, and give insights that way. Another feature that we have, which we need to give, I think we could use more, back to Michael's point of doing this, but is our playground. So one great thing about that we have on our own documentation sites is if you wrap a line of code in a certain way, it becomes runnable in the browser. And that's a really powerful feature. Although I think there's ways we could probably extend that to our ecosystem better than we have. So I think good food for thought on how to make that more usable. Our team is working on specific, our big focus for ours this year and next is really improving the onboarding experience and making tutorials and deeper experiences so people can start using Go more. And so, we're looking at different ways to do interactive tutorials and connect our documentation more. But I don't know, I think the question of what's next for modern language, it feels like there's more iterative changes to me rather than like this big paradigm shift of things. I feel like there's just a lot of polish that needs to happen.
Steve, if you want a suggestion for good onboarding tools, check out Rustlings. That is the best way to learn Rust syntax I've ever seen. It took me a minute to figure out why it wasn't running, but basically the idea is it's Rust code that's broken and you have to fix it for the compiler to work. And it's just like the best tool ever. I'm like a Rust fan of that. It's going to be hard to knock me off the Go bandwagon, but for Rustlings, I love it. It's great and amazing.
Did you know you can be on both bandwagons? There's nothing preventing that from happening.
I know there's definitely not anything preventing it. Just my own mental blocking.
Yeah. I just searched for it. It looks awesome. We should take more time to think of how we could copy from Rust some more.
Yeah, shout out to Carol who worked on Rustlings. It's a really great idea.
Now I'd like to ask that moving outside the language itself, once you have found that Go or Rust is the most suitable technology for your use case, what can we say about the rest? So support, community, hiring, all that surround the language itself.
I can take a stab at the Go side of this. I actually don't know the Rust side as well, but the Go community is large and strong. What we've got, COVID kind of threw off all of our numbers in the way we look at things, but we were supposed to have 40 conferences last year. And the Go community is alive and vibrant on Reddit and on Slack. And there's still meetups happening all over the world, although a lot of them are virtual. Some are starting to be back in person. The ecosystem in terms of libraries I think we've hit a point of maturity where most of the time, if you're looking for something, there's a library that matches your needs and it's a high quality library, especially if you're doing it in Go's kind of sweet spot of CLIs, web, server side, data processing. Even ML is starting to really mature in that. And there's a lot of systems things that are there as well. Networking is another strength that you're going to find it there. Hiring, from what we've heard, is there's a lot of Go developers that are available to hire. Companies are able to hire them pretty easily. But I think more important, companies have found that they don't need to hire Go programmers very much, that they can convert other programmers to Go programmers very easy. And we've have several case studies on go.dev that talk about that from American Express and Capital One, both mentioned that, and there's probably several others I can't remember off the top of my head, but So I think the support's there. And if you think broader than that, like every cloud platform has support for Go as one of their like standard languages. Most services do at this point. And so if you're choosing Go, you generally have all the options that you'd have for, Java or Python or the other languages in terms of services and tooling and all of that. So I think at this point, Go has hit that sweet spot. It wasn't true 5 years ago, but I think it's true today, where really Go, you're not saying no to anything by choosing Go.
I think on the Rust side, we've seen a really significant change. So a couple of years ago, we were running a yearly survey, and in the survey, we saw that match up with some of what other developer surveys were saying. People loved Rust. Rust gets voted like the most loved programming language. It's happened like 4 or 5 years in a row at this point, which is awesome. There's a lot of enthusiasm. People will pick it up. They really like it. But there wasn't jobs. Like there were just, the jobs were just few and far between. But that began to change 12 months ago, 18 months ago, especially in the last 12 months. Major software companies have started picking up Rust. They started like hiring whole teams of developers to staff the support of the additional like Rust developments that were happening in the company. So I think there's really been a shift in terms of a lot of people are switching from hobby, like doing Rust in their spare time, to actually being paid Rust developers. I think that's really growing kind of Rust reach into commercial environments. So you'll have, if you're looking for, I would really like to hire a Rust expert, great. I think that in a sense, the expertise is kind of spreading out in terms of they're just not just hobby programmers anymore, but they're coming from actual industrial experience of using Rust.
Yeah, I think 2020 was the year of Rust. Y'all exploded in the last.
Yeah, I would say, yeah, even the earlier this year, 2021 is, it doesn't, like, you've got the foundation, you've got all major software companies announcing that they're using Rust. There's other stuff coming that I can't talk about, which is really exciting. So yeah, it's really cool.
What has surprised me the most is the in the community aspect is this kind of like a hidden Rust community. I feel like, for me at least, the Go community was very out in front of my face. There's GopherCon, which is huge. There's a Slack. There's GoBridge. Like, there's a lot of things. I mean, I run 2 Go meetups and have a Go conference. So, like, the Go community is kind of smacking me in the face a little bit. But I started when COVID hit, and it was like I had to buy all this stuff to give talks and do these presentations. I'm like, well, I might as well jump on Twitch. And so I started getting on Twitch, and like, there's not very many people doing Go on Twitch, but there's a lot of people doing Rust on Twitch. And there's a lot of people watching Rust on Twitch and giving tips for Rust on Twitch. And then I found out that there's a Rust meetup local to me, and now I'm on their Discord, and I think I got half of them to watch this, actually. But they're like giving me tips on what to say. Like, it's a super hidden community of people who have a ton of talent and a ton of knowledge and are really wanting to help. It's not quite as publicized as I have had experience with the Go community, but it's just as embracing and just as supportive and just as willing to help and mentor with projects and with learning and with career development and everything that somebody new coming into the language would want.
One thing I picked up on with Rust is just how many places, how many different sub-communities there are. I found out not too long ago about the Zulip chat, which shocked me that there's just this entire extra place on top of Reddit, on top of mailing lists, on top of the the discourse and everywhere else that I'd already been aware of. So yeah, I've been very impressed with the enthusiasm, the activity, and the willingness of people to come in, help explain a concept, help explain best practices, whatever the case is.
All right. Seems like there is a pause going on now. So thank you so much for answering all those questions from everyone. We are going to open up to the rest of the community who is watching here on Zoom. So if you all, I know you have those burning questions to ask, go ahead and put them in the Q&A chat. You'll see the normal chat and then there's the Q&A chat. We want you to ask those questions in the Q&A chat so we can show them to everyone. So thanks. We already have one from Tim, so I'll go ahead and present this to all of you. And it says, I don't know if it has already been discussed, but what's Go's standpoint on some types and the safety provided when compared to Rust's enum types?
I'm probably the right person to answer this, although I'm probably not the right person on the Go team to answer this, just on this panel. We've had some interesting conversations around some types as it relates to the generic implementation that the generic proposal that we've been working on. All I can say is stay tuned. Like we're aware of it. We're trying to make sure that we get generics just right. And it might take us a couple iterations to get all the components of it that we're looking for. But just know that this is something that's been considered, and you know, whether or not it gets in, that's up in the air still. And I think that's probably it to respond on that one.
Great, thank you. We have another question from Janis, sorry if I am butchering it, who asks, any opinions on name squatting on crates.io?
Yeah. So I know that it does happen. Some people come in and take all the nice names and just do nothing with those crates. It's a known, I guess you could say, like a known, not like a big issue, but is a known issue. So I know that the teams are aware and are kind of thinking about what a creative solution to that would be.
Excellent, thanks. We have one more here, which says, by Luis, who says, can Kotlin be seen as a language in the same space as Rust or Go, since it also targets native?
I can respond a little. This is Steve's opinion, not the Go team's opinion, not Google's opinion, definitely not Google's opinion, just my opinion. I think there's a handful of languages like Kotlin and Swift that are also considered modern languages alongside Rust and Go. And in a sense, you could think of them that way. It's my experience with any of the JVM languages that they don't get very far from Java. And I think that makes it actually quite a bit of a different experience than you'd say like Rust and Go, whereas like Rust and Go really stand on their own. And they're their own systems or their own ecosystem systems, everything, and they're written in their own languages. And whereas Kotlin, that's not really true yet. And so in one sense, I think you can kind of loop it together. In another sense, I think it's a really different experience, and the tooling is different. And in my experience with Kotlin, you can't write much Kotlin before you have to know Java. And it really exposes the underpinnings of Java. And hopefully over time that becomes less and less true. But it really has a Java feel to it, even though the language itself doesn't. The tooling and everything around it really is embedded in that Java space, and I think that distances it a bit.
Great, thank you for that. I don't see any other questions, so if you all are, oh, never mind, just got one from an anonymous attendee who says, why don't we see any Delphi like GUI development IDE with these modern languages like Rust and Go? What's preventing the development?
Sigh. Sorry, go ahead. I was just having a moment. It is such a good reminiscing.
No, good. Well, anyway, what I was going to say is I think this probably falls into the category of difficult and boring problems to solve. And when you get to difficult and boring problems, people who like playing around, hobbyists, are not going to jump in and solve them. The other problem is this space really, you end up in the cross-platform hell of needing to solve this problem multiple different times. And those solutions already exist for other languages. And I think to some extent, people have kind of resigned themselves to these things are not going to exist in languages like Rust and Go. But maybe I know that there are people out there working on GUI solutions in at least Rust and I assume Go as well. But they're solving it in very different ways than the, all right, go ahead, John.
Yeah.
Oh, no, it's fine. That's fine. I think the thing with Delphi that really set it apart that other languages have never really touched since then is this: when you're designing the GUI, you're kind of writing the code at the same time. They're interlocked. So you can be like drawing the GUI in code or literally drawing the GUI in the GUI builder, and that's building the code. And other languages, that's been separated, right? You're either describing it in XML, like you might in the kind of the C# world, you describe what the GUI looks like, or you're describing it in a markup language like JSX, where it's, you don't have a really close connection to what it will be. And as a designer, you can't just start on the GUI design side and get the code as for free. I don't know why. I would love to see more people experiment with intentionally designing a language such that it was capable of being generated automatically and structurally updated, just like you could in Delphi. Most modern languages are too complicated. As Michael's saying, like it's a hard problem. As you add more features to your language, it becomes increasingly hard problem to actually make it that simple and straightforward to interlock your GUI design and your language.
So I'll add a little bit on this too. If you're like Jonathan saying, Delphi took a very specific approach to this, and I think that approach just is untenable today for a widespread language. It's like back when Delphi started, it was really, you pretty much had one target, and now it's like, well, people are building web things. Sometimes they're building web on the browser, sometimes they're on the desktop. It's desktop app, it's mobile apps. Like just the GUI space is grown so much. Maybe it's a gaming system that has a completely different GUI. It's just everything is really expanded, which makes it hard. And there's projects in Go, and I know there's some in Rust that do all those things. We've got a gaming engine in Go, and there's ones that can, in both Go and Rust, there's great ones that can embed a browser, and you can do the interface there with a program. And there's WASM support, and there's lots of things there. So there's work being done, but I just think the world is it's really beyond the scope of either language to really think of it in the Delphi place. And I'd say, but for an analogous, Flutter's somewhat doing this for Dart. I think if you want to look for a tightly integrated GUI experience, Flutter and Dart are doing it, and that's I consider that a modern language that we actually probably should think of in the same boat as Rust and Go. And it's really the GUI language. If you're writing mobile and desktop, and they're starting to do web, and they're really making tons of progress there with that.
All right. Thank you. Oh, sorry. Did someone want to add?
I was reading ahead, so
okay.
You can already tell the next one's a Go question.
Okay, yes. We are actually going to go ahead and do just 2 more questions, so we'll keep it short and sweet. The next one here says, let's see, maybe generics make Go more similar to Rust and loses the core features, simplicity and readability. After release, can there be more competition between Rust and Go, or will they stay in different fields of application?
I don't think so. I don't think people choose Rust over Go because of generics. I think they choose Rust I don't think most people. I think generics and Go are to solve a handful of use cases where it has become a real problem, but most of the people solve that by doing code generation in Go. They don't solve it by moving to Rust. Whereas Rust generics solve a different problem entirely unique to their ecosystem where they're best optimized to run. I don't feel like adding generics to Go will increase competition at all, because the languages still complement each other in the way they complement each other now, right? Like Go is going to still be more readable, quicker to learn, in some ways, faster to develop on, not always, some ways. Whereas Rust, you'll have more control over your memory. You'll have a lot more explicit control and like 12 other things that I don't remember reading about because it's just off the top of my head. Like I don't think they're gonna ever get to the point where they compete, because they just solve two different problems, in my opinion.
I agree with that completely. I actually think generics is overblown for Go. Like it's overhyped. I'll say a little, like particularly as someone on the team helping to design this, although I'm not, I just review the designs the engineering team comes up with. Our team has been working on this for a long time, and it's hard to add generics to a language, but it's really hard to add them to a language and make the language simpler. And that's been our goal. And I think we're really close to accomplishing that goal. If you read the latest spec or the latest proposal, the code actually is more readable with generics, and it actually looks simpler. And we honestly weren't sure if we could do that, but if we couldn't, we wouldn't add generics. And I'm pretty confident that we have. There's going to be side effects that we haven't thought of because it does change the type system in fundamental ways, but I really think it's actually going to be simpler and more readable with generics rather than the current Go code. And read the proposal and see if you agree with that. But I really am optimistic about the approach that we're taking here.
I would take a counterpoint on two aspects of what you just said. One, I actually do think that Rust and Go are often seen as competitor languages. I think people coming from the outside are looking at these two languages as, you want to write something, you want it to be a command line app or a server-side application, you want it to be fast. And sure, there are plenty of differences between the languages, but overall, can they solve the exact same problem in many cases? Yes. There are some things that Go is better for, some that Rust is better for. But I think there's a large group of people out there who are saying, yeah, I got to choose between these two languages. And following up on that, I do think generics is one of those dividing lines. I think when people are analyzing which of these two languages am I willing to work with, some people are going to say, I'd rather choose the simpler language that doesn't force generics on me. And other people are going to say, I don't want to even get started with the language unless it has generics. So I do think it may be, you guys, I think, have both said from inside the Go community, you're not seeing a lot of demand for it. Maybe that's a selection bias. People who are already there are saying, we are happy solving these problems in a different way.
I think you're making a great point. And I think you're right. Outside of Go community, we hear a lot of demand for generics, which one reason we're pursuing it is we do think it'll help unlock adoption for specific use cases. I think you're probably right. People do on a surface have to make a decision between Go and Rust, but I do think as you get into them, it's a clearer choice than a lot of choices are when you're going to use one or the other. And sometimes the answer can be either. And that's a good answer too. If your team knows Rust or if your team knows Go, and it's either, go with that one. But you're making good points that I think it will unlock some things for some people for sure. And we've heard that plenty. Our latest survey and the one before were very clear about that.
Excellent, thank you. Well, everyone, we actually have gone a little over time. We're going to conclude the Q&A actually here, but we're not going to stop the conversation just because this talk is over. We're actually going to direct you all to go ahead and join the Discord so we can go ahead and continue the discussion there. All of our speakers will definitely be there, and so you can ask questions accordingly. And yeah, definitely. Does anyone have anything they would like to add before we conclude our event for tonight? today.
I would like to thank you all for your. I'd like to inform you that we are closing a lot of time zones in this event, and we are living 2 different days. Some is living the 20th, and some is in the 21st. And someone talked about the mascot, and I'd like to share my Q1. So I'm very proud of my Lego crab.
I've decided the only thing stopping me from fully adopting Rust is my lack of a Ferris crab. So I'm in a campaign to find me a Ferris crab so I can fully embrace Rust.
Fantastic. Yes, we'll have to find one for you, definitely. All right. Well, we've seen that both languages are really interesting, and it's likely that more and more developers will have an interest in learning Go or Rust or both. Why not both? So I want to say thank you to all of our speakers here. Thank you for those of you who are just waking up on the other side of the world, and also those of you who are joining us in the evening. We hope that this has satisfied a lot of your curiosities. Like I said, we can continue the discussion on Discord on our channel that we've written in the chat. You can also contact the GoLab team at info@golab.io, or of course you can follow us on the social networks as well. Just one last thing I wanted to let you guys know. We're going to have a few different courses and events going on, so you can find the next events going on at golab.io and rustlab.it. And of course, all of our sessions will be available on social network like YouTube, on the GoLab channel, the RustLab channel. And last but not least, we are going to have a Go course for all of you watching. So if you are watching, we're going to give you 50% off that Go course with the coupon LEARN50GO. So you can go ahead and check out the GoLab for more information on that. All right, so thank you all for joining us. Hope to see you with the next event, and have a wonderful rest of your day.